So it says that the siren of a police car, which is traveling at a constant speed along a straight horizontal road, emits sound waves of constant frequency. A detector P is placed inside the police car. So they're saying that first of all, there's a police car here, right? So this is our police car. And in this police car, there's a detector called, well, detector P. So I'm going to write P over there. It's placed inside the police car, and then a detector Q is placed next to the road at a certain distance away from the car. So at a certain distance away from this car, so let's say maybe a distance of X, we are then going to place a detector Q. So we basically have a detector inside of the police car, and then we have a detector a few meters away at Q, right? So the two detectors record the changes in the air pressure readings caused by the sound waves emitted by the siren as a function of time. Also, by the way, this detector P, it could be here, it could be where I've drawn it, as if though the car is moving towards the detector, or the detector could also possibly be over here, which means that the car would be moving away from the detector. All right, so I'm going to place it at two positions. So just to show that this detector that is here, that is detecting these sound waves, can be placed at any position. They say that now we have a graph which is recording the changes in air pressure, which is caused by the sound waves emitted by the siren. So there's a police siren here, and it's basically emitting sounds. And the two detectors that we have, detector P and detector Q, are detecting the sound waves which are emitted by this police siren. So now we have two graphs, right? We've got graph A and graph B. Both of these graphs are basically showing how these sound waves are emitted by doing what? By measuring the air pressure. So you can see that graph A says it's the air pressure versus the time recorded by detector P, right? So this is basically detecting the sound waves of the police car by the detector that is in the car, right? And then the next one is by detector Q, which is next to the road. So we'll say that it is a detector that is away from the car. Okay, so we've got these two graphs essentially. And what you're basically seeing in these two graphs from your general knowledge that you guys know is we see two waves, right? So we've got this wave and then we've got that wave over there. And those waves are basically a measurement or an indication or a drawing of how these sound waves are emitted, okay, and how they're recorded by these detectors. So just a quick recap, if you guys remember, we have what we call frequency, right? So frequency is basically the amount of wave within a certain amount of time, or within 1 second, essentially. That is what frequency is. And then period is basically the amount of wave, while how long it takes for one wave to be completed. So again, we've got a period, which is basically how long it takes for one wave, and one wave is the one that I've drawn, that I've highlighted in yellow. So it means that maybe the period for graph A would be 17 seconds. Also, by the way, guys, if you guys want to ask a question, please just unmute, because I'm not really too focused on the chat. And if anyone, yeah, so you can just unmute and ask your question. Right, so quick revision is that we've got what we call period, and period is how long it takes for one wave to form, right? And that's what we have here. For graph B, if this is a complete wave, it means that the period for that wave would be 18 seconds. But frequency is basically the amount of wave that is formed within 1 second, right? So what does that mean? It means that if I look at my two graphs, I have 8.5. In 8.5 seconds, I can say that a half of a wave is formed. But in 17 seconds, I can say that a full wave is formed. So that's why we say that this is our period, right? But then in 1 second, how much of a wave was formed in 1 second? It would probably be over here. This looks like maybe it's a quarter of a full wave, because this would be a quarter. Well, actually, that's not a quarter, because if this would be a half of a wave and this is a full complete wave, then this would be a quarter of a wave, and then maybe this would be a third of a wave. Just quick revision. Okay, so it's frequency and period. Period is the time that it takes for a full wave to form. So like this, right? Not this entire length of the wave there, because that entire length is indicating that this is one wave, and then this half of the wave is another half, right? So for us to talk about period, we need to talk about one wave that is formed. And same with graph B, if we had to talk about the period here, we wouldn't say that the period is 27 seconds. Why? Because in 27 seconds, we're able to form one wave, which is this one. This is one wave. And then we also form half of a wave. That is how much is formed in 27 seconds. So that wouldn't be the period. All right, cool. So that was just quick revision. Now, getting into the questions. They say that different patterns are shown above for the same sound wave emitted by the siren. So there's a siren. The siren is coming from the police car, but there are different patterns that are shown. What phenomenon is illustrated by the two detectors showing the different patterns? So this phenomenon, where we're basically seeing a pattern of air pressure, or basically sound waves, and how they are emitted over time, this is called the Doppler effect. Okay, so these two graphs are showing us the Doppler effect, because graph A is basically recording, or I'll say listening to the sound waves as it is in the car, whereas graph B is showing us how the sound waves are recorded as the detector Q is far away, right? So we've got a car, and then we've got a detector P there and a detector Q there. So both graphs are basically just showing you the Doppler effect, right?